As already discussed on Monday, I did the Diet Coke and Mentos experiment, which has been done a million times by a million different people. But like I said, I haven't found any real data that said how many Mentos dropped into the Coke would affect the height of the reaction. So that's what I decided to do my presentation over. The first thing that we have to talk about is the science behind the fun, as the thing shows. So to do this, you have to understand the chemical and physical properties of both the Diet Coke and the Mentos. So first, the Diet Coke. Diet Coke, like any other soda, everyone knows, contains high amounts of carbonation. And Diet Coke especially is good for this experiment because it also contains aspartame, which you'll figure out what its role is in a minute. The Mentos are kind of the key to the reaction. If you were to zoom in on a Mentos and look at it, the surface of it would look a lot like a golf ball. It has all kinds of little bitty pits and dimples in it. And whenever these two are combined, those pits and dimples provide places for the carbonation to build up and then to be released really quickly. And the aspartame speeds this process up. That's why it works better with Diet Coke than it does with like a regular Coke or a Sprite or something of that sort. Okay, so my question is, do the number of Mentos put into the Coke affect how high it will shoot? That was my question. So here are the supplies I bought. This is roughly $20 worth of Diet Coke and Mentos, if anyone was wondering. So, first thing, this is us. This is me and my brother. That's the other guy there. We were setting this up. This is my mom's house, and that's our front door. And it's kind of high. What I did, I decided to mark the house, since we have a white brick house. You'll see it in a second, but I decided to mark the house with blue tape. And I did it every foot. So my measurements in a minute that I give you are only accurate to the nearest foot. They're not, I can't validate anything in between. And there's a front shot of it. If you see the black part of the roof right there on the very top tip corner, that's 16 feet. Our roof is exactly 16 feet tall at that point. So that's what I was going by, so I can give you a gauge as to how high everything is. Okay, and here is my first experiment. And the little thing that I have in my hand, it's just a cut piece of PVC pipe that I can put my Mentos in and then drop them in there so that it wasn't like, I wasn't dropping one at a time, stuff like that, okay? And I had a piece of cardboard that I just slid out and put it in there. All right, my first one. And there's no sound.
Turn the volume up. All right, and I have to go ahead and apologize. My mom was watching this experiment, and she was amazed. I don't know what it was. She teaches school at an elementary school, but she had never heard of this somehow. And she was watching, and she blurts out a couple times. So you just have to excuse her. All right, so this is my Mentos dropper thing. That's all. All right, there's one Mentos. You missed the first part of it. I said that there was one Mentos being dropped into there. Okay, the second one, two Mentos, same exact thing. I bought all the Cokes at the same time. So 2 liters of Coke, 2 Mentos. All right, Diet Coke Mentos experiment 2 with 2 Mentos. Big difference between 1 and 2. So I kind of already could confirm some of my data, but couldn't stop after 2 because I had a lot more Diet Coke left. All right, Diet Coke Mentos experiment 3, 3 Mentos.
slide them further. We'll go over the numbers in a minute. I have all that written down on a different page.
All right, Diet Coke Mentos experiment 4 Mentos.
And the reason I decided to show all these is because they are kind of exciting and they're kind of cool to watch. I could have just showed one and done that. See him a little bit bigger.
Diet Coke Mentos experiment 5 Mentos.
And my mom's house is getting sprayed with Diet Coke. She doesn't like that too much. All right, and the last one I went from 5 to 10. Okay, trying to see if there was a big difference. I ran out of the large Diet Coke at this point.
Go big, go home.
That's what I was thinking.
That's what I like.
My brother really zoomed out because he didn't know what he was doing. But it was about the same as 5. It wasn't a whole lot of difference. So, here are the numbers that I gathered from this. And of course, what I already said, these numbers, the height in feet, are, I can only measure it to the nearest foot. Like I can gauge, I looked at the video to gauge how high they went in between. And you can see I kind of got an anomaly for, I don't know what's an anomaly, just something weird. But I got more, it went higher with 5 than it did with 10. And I talked to Dr. Almond, or Mr. Almond about that. And I kind of did some more research, and I think it was all right to put that into the presentation. And here is the scatter plot that I had, and I'll go over the equation in a minute. And it shows, I chose a natural log regression line for this because from what I can tell from my data and from the data that I've looked up, that this is kind of going, that line should right there should sort of flatten out as it keeps on going, so it shouldn't just keep going up forever, so you can't put 1,000 Mentos in there and make it shoot, you know, so much higher. So that should flatten out and hit some kind of an asymptote right there. Okay, there's the formula. It's the same one as on the other page. So where y equals the height of the reaction, x is the number of Mentos, the LN number with the x and the 4.5, that's your slope function. So that was how fast or slow that the slope increased or decreased. The intercept function is, of course, 3.0 or whatever. And it's kind of weird with a natural log because it never actually crosses the x-axis. So it's called the intercept function, but I think it's called the intercept function, but it never actually crosses the intercept there. And then the r squared number that I got from this equation, that's how good that the variation in y can be explained by the relationship in x and y. So this is about 88%, 88% a little bit higher. So that's pretty good. That means this graph does a pretty good job at explaining how the x and y variables relate to each other. So what I decided to do was, since I also bought small Cokes, and I was going to reenact this using the small ones, see if I could get similar data. But you'll see in a minute, I kind of ran into a problem. So it won't take long to show this.
Diet Coke and Mentos, experiment 7. This is 1 Mentos again, but with a 16.9 ounce Diet Coke.
This one isn't very exciting. It's not like the others. Not much happening at all. So we go on, and the next one is 2, which is a little bit better.
Diet Coke and Mentos, experiment 8. 2 Mentos and a small Coke. So, and then on to, oh, how do I back
Backspace.
that? Backspace? Gotta hurry up. Okay, then I went to 3, and this is where the five
experiment
thing
number
happened.
9, small Diet Coke and 3 minutes.
Blow up.
I was expecting to shoot higher, but it actually did a lot like it did on the first one. So does anyone have an idea of what could have happened on that one? Anyone, any idea?
Kind of the same thing that happened when you took the 5 to 10, it kind of did the same thing.
I kind of thought that at first, but then I realized something, that I got home late Friday night and my mom was asleep. So she just saw a bunch of Diet Coke sitting on the table. So she took 3 of the small ones and put them into the refrigerator. And it just so happened that the one that I shot off first and third were cold. And the second one was warm. So I had another question to see whether hot and cold made a difference. And that was my second question. And so I did it once with a cold and 5 Mentos, small
Diet
Diet
Coke
Coke, 5
Mentos
Mentos.
experiment 10. This is with a cold, small Diet Coke and 5 Mentos.
And not much of anything. So then I did it warm.
Diet Coke Mentos
Just room
experiment
temperature,
11.
room temperature
This is
was.
a small Diet Coke warm with 5 Mentos.
So it's a little bit more of a reaction there. All right, so I think the answers to my question were that 1, my first question, that the number of Mentos does affect the height of the reaction, and 2, that the temperature also affects the height of the reaction. And I have one more clip, but I think I'm out of time. So, it's okay.
Questions for Nathan?
Okay.
Do you think that the time it took for you to, because I saw it differed with each one, the time it took for you to pop the top off and get the Mentos in there, do you think that had anything to do with it?
I guess it could, because it would release a little bit more carbonation, but I tried to do it.
Right, I mean,
That's why I set them there with the lid on and I opened them in every single one, so I guess that was almost as close as I could make it to that experiment. Anything else?
Can you go back to your conclusion page, please?
Maybe.
If you were saying that.
Or just explain how your data supported your conclusions, please.
Okay, well, as you see from the videos and the graph, that I think what my conclusion said for the first question was that the number of Mentos does affect the height of the reaction until it gets to a certain number of Mentos. I think that's what it actually said on the thing. And you can tell that just from the different videos and the different information, that it was a graph that was curving upward. And the second one was the result of the other 2 experiments, that I put 5 in the cold Diet Coke and it just kind of fizzled, and then I also put 5 in the warm and it actually had a reaction. So I think it does make a difference. Any other questions?
I think you can pull your graph up again.
Okay.
I think you're exactly right. That is a logarithmic function. That's what it seems to match up to best. Yeah, right there. So which one of your data points is the outlier?
Probably say it's one of these 2.
Well, okay, I agree it's one of those 2. Which one do you think? Which one do you feel probably doesn't belong in the pattern?
Maybe that one.
Probably that one, and it,
Yeah,
probably
it's
if we
the
can go
farthest
back and
out.
repeat that one,
Yeah.
we get something different. You're secondary math?
Yes.
Okay. Just, and don't do this today, but just at some time, at some point, I want you to think again about what those numbers are. You were talking about as the y-intercept function and the slope function.
Mhm.
Think more about what they are, and I do want to correct one thing you said. You talked about the fact that, this logarithmic function went up and came to some type of asymptote.
Uh-huh.
Logarithmic functions never do.
Okay.
They start slowing down, but there is no ultimate
Okay.
height. So I guess if indeed this fits this model, then in pure theory, we could put enough Mentos in there to get it as high as we want,
Okay.
in pure theory. Then I have one last question. How many experiments did you do?
6 with the large one, and then I meant to repeat it with 6 with the small one, but then it didn't work out.
Okay, and this is a picky point, but Leanne, help me with my terminology. How many, do you agree that he did that many experiments, or will we call those trials?
He did one trial.
Okay.
You did one experiment with multiple trials, is that right?
Yes.
Okay. So
Yeah.
it was one experiment, but you did umpteen trials. Okay.
Nathan, and it's not, can you help explain how you estimated your heights?
I looked at the video.
Okay, so when you have like 0.5 or
That,
whatever,
I can't account for that completely, that's just, if we go up a little.
by the
higher,
estimation on the video?
Yes, by the estimation on the video.
Yeah, because that was the other question I had for you. You made the comment early in your presentation that it was only accurate to the nearest foot,
Yeah,
and then you presented things at point this and point
Well, yeah,
that,
I
and
see.
you were doing the best you could off of the